Hello, my name is Aurimas Liutikas, and I'll be talking to you about Gradle build system. You might have been pulled in by the clickbaity title, but I'm hoping that through this talk you kind of get to see and give you kind of appreciation of why Gradle can be difficult to learn, and then what we can do about it as a community. All right, so who am I? First about me. I have been at Google for a little over 12 years, and 8.5 of those years I've been on the Android X team. While working on Android X, most of the time I was working with Gradle at some capacity, and thus I had a privilege and pleasure of stepping on every rake that Gradle has created out there. My current role, I work a lot with Android Studio team, work with Gradle and JetBrains, and trying to kind of help shape the ecosystem and the tools around in those system. So let's get to it, to the big question, is Gradle a bad build tool? And I think it's not. Because when it works, it's actually pretty amazing. When you have it do the thing you want it to do, it works well and actually scales pretty well. And as an example, I kind of take Android X as an example. It's one of the largest open source Gradle projects out there, and it's done pretty well for us. And to kind of walk you through a journey of how it went for us, I'm going to give you a couple of graphs. So this is one of the things you can see. This is a number of Gradle projects within Android X. We've grown in the last 4 years, pretty much doubled the count. It was around 400 projects, and now we have close to 800. During that same amount of time, the lines of code of Java and Kotlin have gone from a little over 1 million to over 3. So that's more than double in the amount of code that we have. So it's pretty, staggering growth, I would say. And during that same time, this is the graph that shows our ephemeral CI that's running with, remote build cache. And it's showing the slowest kind of target that is kind of blocking pre-submit, which is essentially like a PR verification step. And you can kind of see that our build times actually decreased during the time when we doubled in number of projects and more than doubled the amount of lines of code. So, hopefully to you that makes you feel like, okay, so like you can scale, you can make Gradle do the things you want it for you. And kind of jumping in on what the local experience is like. So this is a graph for like last 90 days using Gradle Enterprise or Develocity. And you can kind of see that our mean assemble debug, which is essentially someone running tests, is about 11 seconds. So, it's pretty fast, I would say, right? Like if you want to do iterations, it's actually very much workable while our code base is pretty darn large. So you're like, okay, the end, this 2-minute talk was well done. We're finished. But there's kind of a little bit more to it. And let's talk about that. So as project grows, you really need a build engineer. And what I mean by it is someone who specializes in build and is separate from someone who's developing software. If you're writing an app, if you're writing a library, you have a very different set of skills than someone who's working on the build. And specifically in Android X, we've had about 1.5 SWEs working on a build this whole time for 4 years to make the number, to have the numbers that we have. And it's not great that you have to invest that much to get the experience there. And sadly, the path of becoming a Gradle build engineer is actually quite treacherous. There's a little echo here. And it doesn't help. As we ramp up new people on the team, we have to do a lot of training. We have to do a lot of work in code review, kind of getting them up to speed because, the system that you're jumping into is pretty complex. And I think the best way to kind of explain why it is so difficult to learn Gradle is going through examples because, that's how I learned. I tried to do things in Gradle. I shot myself in the foot. I learned the hard way. And hopefully, this talk can kind of give you a little bit of sense of like how do you avoid some of these common pitfalls. So let's look at some examples. I'm going to walk through for some things you might want to do in Gradle, how you might try to do them, and why it's the wrong way to do that. And then, of course, like how do you recover out of that state. So probably the smallest hello world type thing in Gradle is writing a task, right? You want to do some work. If you're writing an Android app, you might want to be generating some artifact. You want to generate a resource. You want to do some validation, anything you might want to do. You're creating a task. So what you might do, let's say I'm going to go say create a task. You give it a name. And inside of the Lambda, you go and put in the work, right? That's what it kind of leads you to when you go and write authoring this stuff. And the Lambda, makes it look like that's the thing you would execute. So, you write this thing and you try to run it and you're like, okay, let me run my task. It spent the 5 seconds doing the thing that it was telling you to do. And then overall, it took 6 seconds. So it seems like it's doing exactly what you thought it would do. But then you try to run a different task that's unrelated to the one you just wrote. And you're also spending 5 seconds. And you're like, what the fuck? What happened? Why am I doing this work? And that's kind of the first pitfall, I would say, that you might fall into. The important bit here is the thing you put in the Lambda is actually a task configuration. It is not a thing you want to do to actually execute the task. And so you're like, what on earth is task configuration? And that's where we're gonna have to like look at the Gradle lifecycle and understand what's going on. So Gradle roughly has 3 lifecycle steps, phases. Initialization, not very interesting, not relevant to this one, but we have configuration and we have execution. Configuration phase takes your build.gradle KTS files and then converts that into essentially a graph of tasks that could be executed. And then the execution phase takes that graph and actually starts running them, right? And then the Lambda that is showing to you there is actually supposed to be the things you do to prepare for your task, not actually running the task. But the way it's written, like pretty much every place you might, write code, for example, compose. Anything you put in Lambda is actually execution, like it's the thing you want to do. Whereas in Gradle, it's like a thing to prepare for running the task. So what is the right, quote unquote, right way to do this? Is you write a custom task, right? You have a thing that has a task action, which is the bit you want to actually execute, and there's a separate bit, that creates a task, right? So if we kind of focus on what runs when, task.create runs during the configuration phase. So that's, that happens. You do that step. But then the actual task execution won't run until you actually run the task. So if you go back now and run the jar task and you've written it this way, there will be no extra time spent. So that's kind of like what you want to do. The eagle eye ones of you might have spotted there was kind of one more issue with the example that I just had on the slide, is that if you have some very expensive configuration steps, so it might be querying something, computing something somewhat expensive, you might still have time spent in that configuration during the configuration phase. And that's because you're using tasks.create. And you're like, okay, well, that sounds like what I want to do. I want to create a task. But what you want to do is you want to register a task because the configuration can be expensive. And so what you want to do is you want to use register because that allows you to run that Lambda and defer it to later. And specifically what this means is Gradle has created a system. They found that configuration can be expensive. And so in order to avoid it, they created a system called lazy configuration or lazy tasks that allows you to not run these configuration Lambdas until you actually need it. So if a task you specified in your Gradle W invocation is not needed to run, it won't run the configuration when you do the register path. If you do the create path, it'll always run no matter what task you run. So it kind of gives you an ability to minimize the amount of work you do, kind of like deferring as much as possible, right? Like the first step was deferring from configuration phase to the task execution phase, and then this is deferring it from when you need it to actually, using it on the right time. So what are some of the lessons? Gradle should really deprecate task container create. Like it's wild to me that it has not been deprecated. I filed this bug in 2021, and it still has not been, fixed. So it's sad. It should be deprecated. If you're a build engineer, what should you do? Well, you should really understand the difference between a configuration phase and execution phase. Because if you're confused, and it can be confusing because it's all within the same block of code, you really should like kind of read up on it and understand when things happen. A good way to kind of like play around with it is good old print log statements or a debugger, and put a breakpoint. Is like, is it executing when I think it's executing? And that will give you some confidence of like when should you be running all these things. And then the important part is like kind of avoid expensive work and configuration in general. Like if you can defer it to a task, the best. And then if you can't avoid it, then use lazy tasks so you only actually do the stuff and you need to. And then finally, if you're a plugin author, which hopefully some of you are, is you should use the Android X lint checks that we've written for Gradle that will help you catch calls to these methods that should have been deprecated that are not. So it will flag you and be like, okay, please don't call create. That's silly. You should use register instead. All right. So another thing you might do is you might want to configure some of these tasks. Specifically, some plugin might have created some tasks for you or registered them, and you want to make sure that you set them up in a custom way. You might want to add extra inputs. You might want to re-change something about it. So how would you go about it? Naive assumption is you kind of go to tasks, viv type, and let's say I want to take my better task, and then I just configure it, right? And it's, we're done. No, we're not. This undoes all of the laziness work that you just did. If you went ahead and you registered a task, and then you run this block, you will actually initialize every single one of these tasks. Because viv type is not lazy. It takes this container and actually creates the tasks so it can configure them. The fixed version is adding .configure each. If this is not obvious, I hope it's not, because it's not obvious. You have to know about this, right? And Gradle does not warn you in any way. It will just let you do it. There will be no warnings, no complaints. It will just run. It will just run slower, right? So this is kind of one of those kind of gotchas. And you might think like, okay, this is one to remember. Aurimas, you solved my problems. This is all of the APIs you need to avoid. Task create, get by path, find by path, and so on. Every single one of them, it'll make your tasks unlazy. And even worse, task container implements a collection. So any Kotlin standard library method that acts on a collection. So for example, if you do tasks.any and you put a lambda in there, you're going to blow through your lazy task configuration right away. So don't call any of these. It's terrible. And Gradle has written up a documentation in a separate page that says, here are the things to avoid, and here's what you should do instead. But this is not in Java docs on any of these methods. So you just have to know this page exists, find it, and actually follow that practice. So what are some of the lessons here? Gradle should really deprecate all of these things. I mean, you might see a theme here as I go through this, but task container, task collection, domain object collection, every method that is not registered, named, or configure each should just be deprecated, because every single one of them will undo the work you worked hard to do registering on. If you're a build engineer, what can you do? You can create a task that actually will blow up your build if someone makes your tasks unlazy. So what I call this is eager canary. Just put a configuration block that will throw an exception whenever this is configured. And if you don't call this task, which you shouldn't, and someone goes and does .all, your build will blow up and you won't be able to land that change, which is exactly kind of what you want. And then, you kind of have to have a understanding of like what is, the early versus lazy execution for tasks here. And if you're a Gradle plugin author, again, I'm plugging the same thing again, lint checks will actually flag all of the methods you shouldn't call because, they're not deprecated, so how would you know? Right. The next thing you might want to do is you might want to wire some tasks together. So let's say you might want to have a task that generates a Android resource that you want to put inside of your app, and then you have a separate thing that validates that the thing you generated is actually accurate, right? So you have a file write, file read. So what you might do is, you might want to have a task that's called foo writer. It has a single output file, and then when you do the work, it just writes hello into it. This is trivial example, but that's what it does. And then you have the other task that's called foo reader that has an input file, and then it reads that and it prints it to the console. So it's very, very simple stuff, but kind of shows you how you might want to use it. So how do you wire them up? A naive approach would be, I will take something from the build directory, let's call it foo.txt, and I set that to the writer and a reader. And some of you probably are like, this doesn't look good. So let's say what happens if you try to run the foo reader. The build will fail, and it will say, there is no file foo.txt. What are you talking about? And why does that happen is you did not tell Gradle that there is a connection between the two tasks, the writer and the reader. And, well, because Gradle doesn't know, it will try to run and be like, oh, there's no file. Even worse, if you ran the foo writer first and then write a reader, it will work and succeed. So now you have this unpredictable behavior because you have not declared your inputs. And you have not told Gradle that there's an interconnection between the two. So one thing you might want to do, or Stack Overflow will tell you about, is you just use depends on and you slap it on and it works. And it will for a while until someone goes and refactors your build code and changes what generates the foo.txt. You go to change it to a different task and you keep the old depends on and the things will not work again, right? So this is kind of a band-aid fix to a problem. And it was the only way to do dependencies in the past in Gradle. But there's a better way now. Gradle created a new API to let you express that. And what that looks like is instead of saying, you have a file and you depend on it and you cause the thing, what you can say is, for the input for the reader, I want the output of this task that's called a writer. And flatmath, this helper method, what it allows you to do is to create a provider of that file that not only gives you a right path on the file system, it also carries a task dependency. So whenever you need to read that file, Gradle knows that you need to run the writer task to actually produce that file. So this is a lot more robust. You can go and refactor a lot of your code, and it will be very obvious where your dependencies are. Cool. All right. So what are some of the lessons here? Gradle should deprecate depends on. There's almost every single usage of it is a mistake, right? You should be probably using flatmap somewhere, or some other mechanism. The only kind of semi-legitimate usage of it is if you have like anchor type tasks where you say like build or check or something like that, where you're just like plugging a bunch of things on it and saying like, okay, if you run that, you should run everything. But for every other place, it depends on is a mistake. If you're a build engineer, you should just use flat map everywhere. Like if you see depends on somewhere in your build, you probably should rethink it and be very explicit on which inputs are needed there. So you should just do that. Okay. Another thing you might do as someone who works on builds, you might run your build twice, right? That seems like probably a common thing to do. So let's look what happens for the kind of example we had before. If we run our task again, we'll see that one task executed again, and that seems suspicious, right? Because we wrote the same hello.txt. Why did the task run again? And the gotcha is that Gradle will always rerun tasks if they don't declare any outputs. It will not warn you about it. It will not say anything, but it will just rerun every time. So the reader task that we had, it will just run over and over again every time because you've not declared any outputs to it. Right, so some of the lessons. I think Gradle should force authors of tasks to actually mark your task to have an output, or explicitly say, please always run this task every time. Right, like that would be a good mechanism because then it makes the task author decide and kind of make an explicit decision, where today it just reruns every time. And it's for legacy reasons, they chose that, but I think it's time to kind of go and change that default. And if you're a build engineer, you should really declare outputs to all of your tasks. Most of the time it makes sense, you probably forgot to put at output file somewhere. But if your task literally has no output, so an example would be some sort of validation task. If you're running a task that just reads the file and makes sure the contents are correct, you don't really have an output to put in there. So you can write yourself a little helper function called cache even if no outputs. And what that does, it essentially shoves in there a placeholder output for you. And this will allow to make sure that Gradle doesn't rerun that task over and over again. It will run it once and it's done. And you might think like, is this like a micro optimization? Like my tasks are very fast. Like why do I need this? When you get to a build that has 800 projects, every single one of these multi-millisecond tasks add up very quickly, especially in CI, right? If you're not hitting cache anymore, you're like doing a lot of work. So that's why you want to like think about that. Okay. Another thing you might want to do in your build, you might delete your build output every once in a while, or you might check out one branch, run a build, and then check out the other branch again. And then now you're dealing with kind of the fact that your build outputs are changing. So let's see what happens. Let's say I have a task that I call foo enhancer. It takes an input and an output, so we're doing all the right things. We're declaring inputs, declaring outputs, and what it does, it reads the file and then adds a beautiful exclamation point at the end of the file, which is very important. So I run this task once. It executes, so it does the thing that we expect. But then if you run the build again after deleting the build directory, you'll see that this task had to rerun again from scratch. And you see there's kind of two steps here. Is the build caching, and it talks about up-to-dateness. And you're like, what on earth are those two things? So let's talk about that. Up-to-dateness, it's a feature that's default on in Gradle. And what it does, if your inputs and outputs of the task have not changed, it will skip the task, right? If you declared your inputs and outputs and Gradle's like, oh, timestamps haven't changed, we're done, yay, good. But if you go and delete your outputs, that means that up-to-dateness will not work because the files that are outputs are gone. And so you will just be rerunning it over and over again. There's another mechanism called from cache or build cache. This is default off. And what it does is if you've already computed this output at some point, it can use the essentially a hash, a key of that task and restore it from a previous execution. You should enable this. It's a really nice feature. It's default off today. When you turn it on, and we delete the build and then run again, we see that like now this task is not running because caching was not been enabled for this task specifically. And you're like, okay, well that's silly. Why is that the case? Turns out by default, Gradle will not make tasks build cache compatible by default. So you have to explicitly say this task is cacheable. Again, Gradle chose this for for legacy reasons, but once you add this thing, now your cache will be restored. So if you go and delete the build output, and now we run it again, we'll say like I computed a build cache key, which is essentially a hash of all of your inputs, and then now it's able to restore the result. So now what happens if you go check out a branch, you make a build, you go back to the other branch, run it again. Now you are able to reuse the work from before. And this is especially important for things like, DEX tasks or R8 or, APK packaging. There's some very, very heavy tasks in Android. If you don't have a build cache, you're essentially redoing that stuff over and over again. So what's some of the lessons here? Gradle should enable build caching by default. It's really silly that still don't. And they should force task authors to mark all of their tasks explicitly, either cacheable or not cacheable. Today, they just don't tell you anything and they make them non-cacheable. If you're a build engineer, you should really enable the build cache yourself, and then mark your tasks, and except for the tasks that are kind of IO heavy. So if you're like having copy tasks, you're most likely going to be faster locally than going to the network and fetching those cache results there. And then if you're a plugin author, you can actually enable more stricter validation. Gradle by default turns this off, but you can say like, I want stricter validation, and this will actually tell you, you have to choose, do you want this task to be cacheable or not? It'll force you to do the right thing. Right. Another thing you might want to do is you might share some artifacts between projects. So let's say, you have one project that generates some, let's say, zip file, and another project that consumes that zip file. And when I say project, I mean projects within a single build. There's two projects that do that. And there's kind of many use cases. You might be passing jars, you might be passing XML files, anything you like. What you might do to achieve this, let's say we have a project A, it registers the task. This is a task type zip. It takes build.gradle.kts, just trivial, not a very exciting example, but it creates my zip file, and it's just a regular thing. Like so far, we're kind of doing everything that makes sense. And then in project B, you say, okay, I want to find the zip task. I will say project A, tasks, and then you say, I want a task named zip. I cast it to a type zip, and then I use it using flat map, like Aurimas told me, that now my inputs are set up correctly. And this will work, but it is extremely fragile. To kind of prove that it works, what you can use is a really neat, nifty flag in Gradle called --dry run. And what it allows you to do is actually see what tasks would have run if you ran that command. So instead of actually executing and seeing the task run, you can say, like, I just want to see what would run if I did do this. So if I run that, it will say, okay, run project A zip, and then run project zip consumer. And so it's doing kind of the right thing. But the problem is you're setting yourself for fragile behavior, because if someone goes ahead and changes the name of the zip task to zip2, your build will fail now. If the task type changes, your build will fail now. You might gonna do some other type of refactoring. It's just essentially setting up like a lot of fragility in your build that you don't want. Another thing that is a problematic thing there is, because you're poking into the tasks of another project, project A has to be configured before your project B, which is kind of not really a big problem today, where Gradle does configuration of all the projects serially. But now Gradle's moving towards a mechanism that allows you to configure projects in parallel. And if you have this explicit dependency, now you can no longer do these things in parallel, because you're expecting one of them to be done before the other. And even worse, if you want to exchange artifacts in both directions, it's literally impossible, because you would be forcing some tasks to be created on one side and the other at the same time. And so it's essentially a deadlock if you try to do that. All right, so Gradle has created a mechanism to do that in a kind of more agnostic, safe way. And the way to do it is, you create your tasks the way we did before. But the new thing is here, you create a configuration, and this is going to be like a publishing configuration. Inside of that configuration, you want to have some attributes. And what these attributes allow you to do is, if you have them matching on both sides, it will be the way to determine what you want to get out of that specific project. So in here, I create one called special zip attribute, and that will be just a way to designate of like, what am I publishing? Like, what could other people consume from me? And then finally, what you want to do is you want to add some artifacts into that configuration so people can resolve something. So you say, I want in the zip publish configuration to publish this zip artifact task that we created in a couple of lines above. And then in the project B, you say, okay, I want to create a configuration for consuming these things. And then you set up the exact same attributes as you do in the other side. And that will allow you to essentially do matching of what you want. And this is like a very simplified example. In reality, you will want a lot more than one attribute, because you could have attribute collision if you end up picking just one. But that lets you set up that bit. And then finally, with some, you can add some dependencies here. So in this case, I want it to depend on a project A that is setting up the publishing. But here, one nice thing about this, you can actually have more than one project. So for example, if you wanted to consume artifacts from project A, project C, project F, you can just add all of them, and it will allow you to retrieve all of them in like a nice kind of distributed way without forcing those projects to be configured, because the only thing you're referencing is the name of the project, and then the attributes are not used until you're trying to use those artifacts. And then finally, with some magic indentation of Gradle, you can say, from this configuration, take the incoming files, use this artifact view transform, and then get a lazy collection out of this. So you have to type it in exact this way for it to work, to be lazy. But if you do that, now you're able to consume that artifact in a way that, when you execute the task, it will know that it has to run this other one. And so if you run it with dry run, again, you'll have the exact same result as we did before, but we're a lot more able to be resilient to any changes in kind of your implementation. So what are some of the lessons? I think by default, Gradle should just forbid cross-project access. Because today, you can do that, and it won't warn you, it won't complain about it in any way. And it should really make the cross-project file sharing easier. I think if you know Gradle well, and you understand what configurations are, what attributes are, what artifacts are, it is possible to do what they want you to do, but there's quite a lot of code, right? So like the first example that I showed that is kind of fragile, it's way fewer lines of code. But the right way is a lot more complex, and you have to write a lot more code. So I think there should be kind of more simplification in that area. If you're a build engineer, we should really test your build with isolated projects equals true. So this is the upcoming feature I mentioned, where configuration could be done in parallel. Instead of just doing everything serially, you can configure all the projects at once. And this will flag all of your cross-project reaches. And you might find stuff you didn't even realize you were doing. So highly recommend to try that and fix up all of your violations. All right, next thing you might want to do is you might want to reuse some expensive work between projects. And now what could happen like that? So in Android X, for example, we run tests for our WASM Kotlin multi-platform projects in the browser. Like we need Chrome to be able to run those tests. One thing you might want to do is you might take that zip archive of Chrome that is in our checkout, extract it in every project, and then run your tests. But that's kind of problematic because you're doing this extracting over and over again, filling up your build directories with copies of Chrome, thousands of them potentially. What would be better is to have a way to do it kind of centralized in one place where it happens once and you reuse the work. And there's many other examples of kind of reusing work across projects that's the same. So Gradle provides you a really nice kind of mechanism for this. They call it build service. So in my case, let's say I have my build service, and all it has inside of it is an expensive value calculation. Here I thread sleep, but it could be a network operation. It could be expensive. I'm computing the thousandth value of pi. Whatever it is, right? It's expensive. And then you can actually even pass some parameters. So if you need to do some file I/O or something like that, you can pass in file directories and things like that to let the service do that. And then when you create your own plugin, you can say like, okay, register the service if it is not yet registered by some other project. And in your task, you can say, I'm going to use this service provider, like the service that I created, and it just works. It does the right thing, right? You apply your plugin, you execute your task. It takes 7 seconds because it spent 5 of those doing the expensive value computation. However, if you go to project B and you're like, I also want to apply my plugin here, but this plugin this project was applying a Kotlin format plugin because you like your code very nicely formatted. You will run your build again, and you will see your build will fail, and you will read this message and you're like, what on earth does this say? You'll see at the task and be like, okay, it's trying to set a service, my service input, and it wants to receive my build service, but instead it got my build service. And you're like, what on earth? Like, it's the exact same value. What is happening? And in reality, what happens, I have to kind of go and explain how build class paths work in Gradle to say why this failed. When you take project A, each project essentially has a build class path, which is essentially like what's on the JVM class path to be able to execute all these plugins. If you only apply one plugin, you'll only have that plugin and all of its dependencies on a build class loader. The project B actually has a different class loader because you added a different plugin to it, so they're kind of distinct. And Gradle made a decision that if your class loaders don't match, you cannot share build services between them. it's a decision they made. Is it good? No, I don't think so. But like that's kind of like what they decided. So what you can do to fix this, you go to your root project, build.gradle, and you can add these plugins onto the build class path, but not apply them. So what that will mean is every project in that project will get the exact same build class path. And now if you run that task, now you ran 2 of them. You ran it for project A and project B. It only spent 7 seconds because 5 of those was expensive computation. But then it's actually successfully running because the build class has been aligned between the 2. All right, so by default, I think Gradle should forbid you mismatching of the build class path. It is a marginally useful feature when you're able to invalidate only some of your build tasks in your build. So the reason Gradle allows you to do this mismatch is you might have like distinct set of projects. One of them is publishing jars, and it's a JVM project, and another one is publishing Android libraries. And if they're not interconnected, in theory, you shouldn't invalidate your build cache every time everything changes. And the way invalidation works is based on a hash of your build class path. So that's kind of why they chose to do this, but I think it's a bad idea because it comes with a lot of costs. And if they chose not to, if they choose not to forbid it, I think they should really give you a better error message when you try to use these build services. Like the thing they told you, is kind of useless, and the only way you can find a fix is you Google it and you go find their issue tracker, and you're like, oh, I had this exact same warning. Right, if you're a build engineer, you should just do this mechanism essentially of applying everything in your root project and setting it apply false, right? So this will align your build class path. And one like kind of not intuitive reason to do this is you actually are decreasing your memory usage as well, because every single build class loader needs to be in memory, right? And if you align all of them, that means all of your class loaders are the same, and Gradle doesn't have to create copies and copies and copies of class loaders. So that's another thing to kind of go ahead and do. So you might think, okay, Aurimas is preparing for the talk. He goes and asks in a Gradle channel, what are some of your most hated APIs? Like, what patterns do you don't like? And it was a very heated, vibrant discussion, let's just say that. People have been scarred by so many different things. And some of them I stepped on and some of them I haven't, but a lot of these are kind of like very insightful. So there are many more examples than the stuff I kind of listed out so far. There's easy ways to shoot yourself in the foot, let's just say. I think a lot of it is kind of like at the end of the day, like Gradle needs to be a lot stricter about a lot of things you do. So let's kind of wrap everything up and see what our takeaways here. So if you work at Gradle, and probably none of you are, but maybe you can influence them by suggesting this and starring comment issues in their issue tracker and leaving feedback when you're at conferences and you see someone from Gradle. Is they should really deprecate the APIs that have better alternatives. I think create is a good example. Very, very obvious. You move to register and pretty much no work needs to happen on a developer. It just works for most part, caveats. But, a lot of the places, like even if they don't deprecate, like link to the thing that is better, right? Like today, you can't even find it unless you go to talks like this, or you go and read blog posts that Gradle has done on the latest release of every single Gradle version, right? So it's not really a sustainable way. The other thing is they should really enable helpful features by default. So build cache, the fact that it's off is sad. Like the reason they don't is because in some obscure cases, build cache can make your build slower for a first run, because now you're storing all of these entries into disk. But like I don't know a single project that never checks out a different branch, right? Like if you work and you're able to never change branches, yes, this feature is useless, but like I don't know a single person who needs that, right? So like it should be turned on. Configuration cache is another feature. That one is a little trickier. You might have plugins that are not compatible, but like Gradle should really force everyone. If you have a plugin that is not compatible, boo-hoo, you should turn off your configuration cache, right? It should be on by default. You have to choose to turn it off. And then finally, I think they should enforce best build practices by default. They have this stuff, I mentioned the stricter validation. They have, when you enable configuration caching, when you enable project isolation, they add all of these checks. But like, why aren't all those checks on by default? Like, if they know you're doing the wrong thing, why don't you tell people about it, right? Like, that's what it is. So anyway, takeaway: if you meet anyone from Gradle, make them watch this talk and make them fix this. If you own a build, what can you do? I think you should enable all of these features: build cache, configuration cache. You should test the project isolation to kind of future-proof yourself. Like, you might think like, oh, project isolation is never coming. Like, I think Android X is probably a couple of months away from actually turning it on for some of our build flows. So project isolation is coming, and I would recommend you start looking at it, because what it will do is your configuration time goes from running everything in serial to running everything in parallel on as many number of cores as you have. So it'll be a very drastic change, especially for your Gradle sync time in Studio. So highly recommend spending time on that. And then finally, if you need inspiration, there's a lot of good open source projects out there. AGP team, Android Gradle plugin team, keeps a Gradle recipes project. Very nice, really good to learn things from. Slack has open sourced their Gradle plugin. We've definitely had inspiration where we look at it and we're like, oh yeah, it's a cool thing, we should do that. And then I think, biased, but I think Android X does an interesting thing, with Gradle, and there's a lot of things to learn from. So, just read what our source code does, and maybe that will give you some ideas for your own build as well. And if you have your own Gradle plugin, you should enable our lint checks. Ideally, eventually, when Gradle deprecates all of these things, I will delete my lint checks, I promise. But until that happens, the checks are very helpful. And then also enable the stricter validation that I mentioned on a couple of slides back. All right, so that's mostly what I had. Thanks a lot for your time. This is a picture of my dog Billy, looking very goofy. If you have any questions, we have solid 4 minutes to answer them. So I'll leave takeaways on the screen, but if anyone has any questions, I'm happy to answer them. Yeah, go ahead.
Is some of this getting fixed in the next major release, Gradle 9?
Okay, the question was, is some of this getting fixed in Gradle 9? None of those things, no. No, so the reason I'm thinking is the one thing that I know that they're changing is they're going to recommend configuration cache to be turned on. So we'll give you warning if you don't choose to turn it on. So like there will be an extra kind of log noise to make you think about it. But I think it's still not enough, right? It should be default on, and they should make you choose to turn it off if your build breaks. So no is the answer. Any other questions? Surely there's at least one more Gradle question in this room. No? Okay, here we go.
When I was actually redacting the Gradle scripts, it was actually suggesting me some tips you actually mentioned. Is it coming from Gradle, or it's coming from Google, it's coming from JetBrains, or it's coming...
Yeah, good question. So the question was, sometimes you see some of these suggestions when you write stuff in a build script in IntelliJ or Studio. Where is that coming from? It is coming from IntelliJ Groovy editor. So if you write build.gradle files, it will warn you. If you write build.gradle.kts, you won't, because there's two different teams working on those two different editors, and it's difficult to kind of align everything. And also the people who work on IntelliJ are not Gradle experts, right? So like the right people to do these warnings would be Gradle. But currently it's coming from IntelliJ, and Studio is getting it on build.gradle files, but not on KTS files. Cool. Yeah, go ahead. Yeah. So the question was, how do you learn not old Gradle? Don't read Stack Overflow is definitely one of those. Stack Overflow, like pretty much every single answer is useless for Gradle. I mean, there's some exceptions, obviously. But like generally, I would say looking at real life examples is the best. I think there's now an Android that Google maintains that has some decent Gradle practices there. Slack plugin, our plugin. There's things out there that I would just use that to get inspired by. Gradle is, for 9.0, I guess one thing that Gradle is doing, they're revamping their docs a lot. They hired a tech writer. And I think that's showing. I think some of the stuff that they're like ramping people on is improved. So like giving another chance to Gradle docs on some of the landing pages might be also worth it as well. Yeah, go ahead in the back over there.
Yeah. Did you see any drawbacks to Gradle cache, like leftover caches from another branch showing you things that you shouldn't see?
Yeah, so the question is, are there any downsides of Gradle build cache? Specifically, could you restore incorrect outputs from tasks? It is possible to do that if your tasks are not properly modeled. So if you don't set up your inputs and outputs correctly, it could happen. all the plugins we use, which is things like Android Gradle plugin, Kotlin Gradle plugin, protobuf plugin, a couple others, we've done a pretty good job of extensively testing where we know it doesn't do that, so it actually works correctly. If you have a lot of your own logic, you might have to go and revisit some of that stuff. Some of the validations that we do in our build is we actually run our build twice. We run it once and a second time where we compare if the outputs are the same. So that's one way to kind of make sure that you're not doing something silly. Moving your project to a different subdirectory is another good thing to do because that makes sure that you don't have like absolute paths in your input somewhere. That's another thing to validate. And then the other thing might be is running a build locally, pushing it to a remote cache, and then your coworker running the same build and seeing how much cache hits you have as well. So that will kind of help you balance out some of these things that you might be messing up with the build cache. Yep. Go ahead.
Do you know if Gemini can help with that? Like look at your build and discover any fixes or just offer suggestions? Or you know any efforts to teach you to do that?
Yeah. It's okay. I'll put my Google hat on now. Yes. My kind of more, this is not me Google speaking, this is me Aurimas not working at Google speaking. There is not a lot of good Groovy and Kotlin DSL code examples out there on the internet. So when you teach a tool to learn from those, you pick up all of the mistakes as well. So realistically, I'd say right now it's okay at best. So I think it's not ideal. Yeah, I mean, it would be nice if it did, but like I think picking good examples is hard. Yeah. Go ahead.
I have a question regarding a Gradle plugin called Fat AR.
Mm-hmm.
It's a plugin to merge ARs and embed embed a dependency in your AR before you
Okay.
flush. I wonder if there's any like alternative because this Gradle plugin is not maintained for a long time,
Mhm.
and there's no other way to apply that using it at the moment.
Got it. Yeah, so the question was, there's a fat jar plugin out there that is out of date and is not keeping up with good Gradle practices, what to do. There is a shadow plugin that we use in Android X. It used to be maintained by a solo person somewhere out there, and now it got taken up by a group called Gradle Up, not related to Gradle, some random group of people. That plugin has been pretty decent, and they've been taking patches, so like we fixed some issues in there. But so it's called Shadow plugin. If you search Gradle Shadow plugin, it will be like the first Google search result. Yeah. Anyone else? Oh, here, go ahead. What is my, well, I actually have done a talk, the question was, how do you simplify your build logic when you have many modules in your build? Convention plugins or just binary plugins is the TLDR. I've done a talk a couple of years back. If you look at liutikas.net, my domain, there's a talk recording in there that you can watch. But essentially, kind of extracting common things, throwing it in a plugin, applying it there, and then using that, through the build. Android X is a pretty good example. If you want to look at our source code, we do a lot of that. Like our build files for like trivial projects is pretty much just dependencies. Everything else is kind of extracted, and we use defaults across everything. The other thing you might want to use is Gradle or Android Gradle plugin recently shipped a settings plugin that you can apply to your settings.gradle that lets you pick defaults. So you'd be like, oh, my min SDK is 21, my compile SDK is 35, and that will apply to every single project within the thing. So that lets you centralize some of that as well. Okay, we're done. Thank you for your time. All right, bye.